Okay, so it was e to the negative x squared power series. Hey, there we go. Hey, Jasper. Green pass again. Awesome. We're all happy about that. Okay, so you substitute, right? 1 minus x squared. And it would be plus x to the 4th over 2 factorial minus x to the 6th over 3 factorial. So I can't remember. In the previous one, did we have to write the nth term? I'm not going to really be concerned about it here because we're about to do something with it. It just says use the first 4 terms to approximate integral from 0 to 1 of e to the negative x squared. And this is one of the reasons why you would do a power series, like why we study any of this, because the antiderivative of e to the negative x squared, if you stop and think about it, it seems like it would be easy, but it's not at all. And so perhaps in a situation like this, approximating its antiderivatives evaluation while controlling your error, maybe that would be the best use of your time as opposed to reinventing the wheel and figuring out the closed form antiderivative of this, which there may or may not be. I honestly don't remember.
Wait, how did you make the jump from e to the negative 2x equals that?
E to the negative x squared?
Yeah.
So what I was just rewriting what we did in the previous question at the very end of the video. Did I mess something up?
Oh, I see. Okay, I was just like,
Well, and so
I
then
didn't know where you got that.
that's the short answer to your question. The long answer is substitution, right? So I took negative x squared and I put it wherever I saw an x in that e to the x power series.
I
And
thought you meant like we had to memorize. Like that's
no,
what I was
definitely.
wanting to ask.
Well, you can memorize that if you want. It could show up, but the better way to go would just be to remember to substitute. Yeah, sorry for the confusion there. But yeah, I wanted to just rewrite that from what I did in the video and you guys saw. Okay, so then what we could then say is that the integral from 0 to 1 of e to the negative x squared dx could be approximated by the integral from 0 to 1 of that power series. So 1 minus x squared plus x to the 4th over 2 factorial minus x to the 6th over 3 factorial dx. So this is going to be an approximation, right? There's no doubt. And with this approximation, there's going to be an associated error. And so, of course, it mentions something about that. So I'm going to go ahead and try and do this out, with antiderivative and FTC1. So this would be x minus 1/3 x cubed plus x to the 5th over 10 minus x to the 7th over 42.
Why are you going to that many when it's only 0 to 1?
Why am I going to that many when it's only 0 to 1?
Because it says first 4 terms.
So we're using the first 4 terms. So the 0 and the 1 would just be our limits of integration, which will come into play right now. So you say evaluator from 0 to 1. But it'll tell you, use this many terms. And 4 seems to be a typical number. Doesn't have to be that, but it seems typical. You good, Hayden?
Yeah.
So again, one of the other side benefits of a polynomial is that whenever you plug a 0 into a polynomial that has all x's for terms, you get 0, don't you? That's kind of nice. So then as you evaluate this, you plug in the 1. You're going to get 1 minus 1/3 plus 1/10 minus 1 over 42 minus 0. Okay, so we could add all those up and do some cool addition with fractions and all that stuff. We don't have to, right? If this were an FRQ, that would be good enough right there. We could stop. Whatever. So we can. Is it okay if we just leave that right there? But let's address the error question, right? Because that's kind of at the heart of this. Because simply we can't say that the number we got is exactly the value of that integral from 0 to 1. There's going to be an error associated with it. So what do you notice about that series that came out of our anti-differentiating? It's an alternating series, and that is so important. So what we can say then is this series is alternating. Therefore, the error, I'll just say error because it uses that word, will be less than or equal to what concept? Yeah, the first neglected term, the one that was showed up next, right? So error is less than or equal to the first neglected term. So then let's figure out what that first neglected term would be. If you look back up in the series that we had, we're going to have to calculate one more term, aren't we? So what would that one more term have been? I'll put it in a different color up there. Minus x to the 6th over 3 factorial. What's the next one?
Plus x to the 4 factorial.
That's right. So you could have used kind of the nth term that we figured out before. Let's try all that again. X to the 8th over 4 factorial. You could use the nth term to generate that, or you could just see the pattern. I mean, either way. It's up to you. Okay, so then if that gets integrated, that's going to be the key to help us with our error. So I'll just slide this in right here. What would be the integral of that?
X to the 9th over 37. No.
X to the 9th, yeah, over 4 factorial times 9. What is it? Is that what it is?
No.
See here, 4 factorial is 24. 24 times 9. 216, I think, right? Isn't it 216? 24 times 9? Yeah.
But you're putting it in the wrong place. 'Cause that's like before you integrate.
Hold on. I put it, you said you put it in the something?
Where you're pointing the arrow to.
Oh, darn it.
Before you integrate.
You're right, I am putting it in the wrong spot. How about right here? So x to the 9th over 216. And then, of course, to get that series, wouldn't we have plugged a 1 into that? So I think I could confidently then say that my error would be less than or equal to 1 over 216. Based on the reasoning that it's an alternating series, we just found the first neglected term. So that would be my max error. So at this point, you'd have to decide, is 1 216th, is that an acceptable max error? Maybe it is, maybe it isn't. You just have to figure that out depending on what you're doing or whatever standard has been set for you. You go with it from there. If it was not good enough, then you just add more terms onto the end of the series, and your error would decrease accordingly. Your max error would decrease accordingly. All right, is that good? Okay, cool. So let's take a look here at number 6. Number 6 will be a little bit different. Yeah, this is where we make a little transition. So in the video and what we just finished right there, all of those essentially had to do with substitution. Number 6, however, doesn't. So here would be what I'd expect, here would be what I would hope, that you'd look at number 6. It says, write the first 4 terms in the general term. You could, I want to be really clear about this, you could reconstruct a Maclaurin series from scratch. You could. You could say, all right, the first term is f of 0, and you plug in a 0. And the next term is f prime of 0 times x, right? So on and so forth. Are you guys focused with me? Okay, good. Or, in my opinion, the far better way would be to look at that and say, that's essentially the exact same series as what? Yeah, the geometric series, but one small thing has been modified, right? Instead of the top being 1, it's an x. So how did that happen? They multiplied by x. So the idea would be to do this. So I'd say the original series, the one that we're going to try to use, would be 1 over 1 minus x. As we saw up there, that's equal to a power series, 1 plus x squared plus x cubed plus ... plus x to the n. And so then what they've done is they've multiplied that 1 over 1 minus x by x. So you are perfectly allowed to do that as long as you do the exact same thing to the other side. So we could then write x over 1 minus x equals, I'll just multiply every single term on the right, including the nth term, by x. So this would be x plus x squared plus x cubed plus x to the 4th plus ... plus x to the what?
N plus 1.
N plus 1. Yeah, that's right. And you're done. So you guys are fast writers. I'm a fast writer. Once we recognize multiplication, this will be done pretty quick, right? 30 seconds or less, maybe. Definitely less than a minute. If you were going to do this by reconstructing a Maclaurin series, 1 minute's probably not going to be your time frame. It's going to be a lot longer than that. So we want to learn to recognize these series and then how to manipulate them to really, honestly, just to make life faster and easier for you instead of having to construct something that you really didn't need to construct. Okay, what do you think? Okay? All right, let's take a look at number 7.
Would the interval of convergence be the same?
Oh, we didn't really talk about that. So interval of convergence. So it's not going to move, right? Because we didn't move the centering point. But I imagine that potentially, I don't know, let's run it really quick. Potentially the endpoints could be different. So I'd start off with the base interval of convergence that we know to be true for the original that we started with. And then we could test the endpoints out, right? So we could go, if x is, it's really, actually it's not going to change anything, is it? So if x is -1, then the series would be sigma of -1 to the n plus 1. That's just going to go -1, 1, -1, 1, -1, 1, or depending on where you start. And then for x equals 1, you're just going to get sigma of 1 to the n plus 1. So that's just going to be 1, 1, 1, 1, 1. So yeah, I'd say the interval of convergence would remain the same. Good question. Okay. Anybody else? Okay, moving on. Looking at number 7. Number 7, I think we can do in a couple different ways, potentially some interesting ways. So take a look at number 7. It says, write the first 4 terms and the general term of that power series. And there is a lot that's going on. I'm going to show you a long way, and then I'm going to show you, maybe you already see it. I'll show you a short way too. But the long way, the concepts in the longer way are pretty important. So what does this look like to you as far as those basic series that you're supposed to be memorizing? Looks like the geometric series, right? It's definitely been modified a lot, but it looks like the geometric series. So take a look at the bottom here first with this fraction. That's not exactly like the power series that we're memorizing, because it's 1 over 1 minus x. So what's happened? Just in the bottom only. What process do you think has happened? Just in the bottom. I don't see multiplication in the bottom. I really don't. Isn't it a substitution again? Do you see how if we replace the x, I'm just talking about the bottom only, I'm not talking about the top yet. If we replace the x with x squared, that would be it, wouldn't it? So let's construct that. Let's see how that goes. Your original series is 1 over 1 minus x. And that's, again, this. I'm going to keep writing this stuff down with all these just in an effort to hopefully help you get these memorized. There you go. So there's our basic series for geometric pattern. And so now we're going to substitute. So I'm going to replace any x's I see with x squareds. So that would look like this. 1 over 1 minus x squared equals 1 plus x squared plus x squared squared plus x squared cubed plus dot 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 plus x to the what? 2n. Right. Okay, so there's that. And now we've got this other thing in the numerator, because clearly you can see over here on the left we've made some progress towards our goal, but the numerator is radically different. What might you think? Yes, if we multiply by 1 plus x, that would do it, wouldn't it? Directly, the left side would be exactly what we want. As long as we do it correctly on the right side, we'd be in pretty good shape. So, let's try that. So if I go 1 plus x multiplied on the left, I get my target. That's okay to do as long as I multiply every single term on the right side by the same thing. So, it's going to look like this. 1 plus x times 1 is just 1 plus x. And then 1 plus x times x squared would look like this. So on and so forth. And if it's okay with you, I'm just going to stop right there. we're going to see enough of what we need to see if we stop there at the x to the fourth. You'll see what I'm talking about here in a second. Plus dot 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 plus 1 plus x times x to the 2n. So including the nth term, you got to multiply everything through by that 1 plus x. It might look like a mess, but if we do all the distributive property stuff, you're going to see something, I think, beautiful take shape. Check this out. Bless you. So if you distribute, what happens? 1 plus x plus, isn't it x squared plus x cubed?
It becomes the same thing.
Plus, yeah, look at that, x to the fourth plus x to the fifth, x. And then if you distribute the nth term part, you end up with x to the 2n plus x to the 2n plus 1. What is this? Isn't this just the geometric series all over again? Even with that nth term, if you think about it, if n is 0, don't you get x to the 0 plus x to the 1? If n is 1, you get x to the 2 plus x to the 3. So it's basically just creating the geometric series 2 terms at a time instead of 1 term at a time. There's a connection to be made here. Yeah, question. What is the connection? What do you see? Yeah, go ahead.
So you multiply both the top and the bottom by 1 plus x, so you're basically multiplying it by 1.
Right. So check this out. Can I show you the exact, kind of the other side of that coin? If you look at the original, maybe you recognize this, maybe you thought, it doesn't matter. Doesn't the denominator factor? It's the difference of squares, right? So you could say 1 plus x, the denominator would be 1 minus x times 1 plus x. And that's the regular old geometric series. So that could have been a way we could have done it. You could have looked at it and said, hey, look at that, this factors out. And, whoa, look, it cancels. So it's just the basic geometric series. Could have been done. Maybe you saw it. I went ahead and did it the way that I did it because I wanted to make a point with this too. But there is definitely a connection. Here's the point I wanted to make. If, like number 7, if there is a combination of things to be done, like let's say you look at it and you're like, well, if I substituted here and multiplied it there, or whatever the combinations of things were, what you want to always do is substitute first. Always substitute first. Okay? Because if you do it the other way, the substitution will propagate itself too far. So substitute first and then multiply if that's the two things you're going to be doing. Substitute first. Okay, good? All right, cool. Nice job. And Drew, your hand was up too. Were you going to point out something? No?
He was just stretching.
He was just stretching. Okay. Well, we'll give you credit. You probably saw it before Sydney, didn't you? Okay, that's what I thought. Okay, let's take a look at our next one here, which is number 8. Yes. Okay. So with number 8, it says, right, the first 4 terms in the general term of the power series right there include the interval of convergence. So this is somewhat similar to the one that you just did. This involves 2 different stages. It involves a substitution and it involves a multiplication. So because we just did one together like that, if you guys would try number 8 on your own for a few minutes, we'll let you do that. And then we'll try to tie it together and show you the solution here in just a little bit. Bless you. Yeah, for like the 4th time in a row, it looks like the geometric series. So we start off by writing that. 1 over 1 minus x is equal to 1 plus x squared plus x cubed plus dot 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 plus x to the n. And we'll do our substitution first. What did you guys figure on what we need to substitute to make this series be what we want it to be?
Negative x minus 2.
Negative x minus 2, right? Let's try it out. I'm getting a couple of looks of like, are you sure? Let's try it out. So if I substitute negative x minus 2, if I replace the x with that, we can just check this real quick to see that yes or no, this does or does not work. So if I were going to do this, I'll erase all this stuff in a second, but if I was going to really do this, I'd distribute the minus sign, right? So it would be 1 plus x plus 2. So I think this does work, doesn't it? in my own brain, I was thinking negative 2 minus x. I don't know why I was thinking that. It's just the, different ordering. Same thing, though. So those of you that were giving me that look of like, huh? Does that make sense?
Yeah, I just like.
Can I show you maybe a process that you could use if you're looking at this and you're just thinking, I got no idea
Yes.
why this would be the way that it is? You could look at it like this. You'd want to recognize that it's a substitution. That's really key. But you could do this. You could say 1 over 1 minus u, where u represents some unknown quantity, right? That would help us figure out our substitution, equals 1 over, what was it again? 3 plus x. And then we'd solve for u. Like u would tell us, or should tell us, what our substitution is supposed to be. So you could cross multiply, you'd get 3 plus x equals 1 minus u. And then you subtract 1, you get 2 plus x equals negative u. And then you divide everything through by a negative 1. And that would tell you what your u would need to be in order to get the expression to substitute. So you can either just sort of see it, or you could run a little process like that to say, all right, it's kind of like a u substitution, right? Like, what does a u need to be to make this work? You could certainly do that if it's not just jumping out at you. Okay, so 1 over 1 minus negative x minus 2 was the proposal that I think is going to work. So we replace all the x's with negative x minus 2. So this would be 1 plus negative x minus 2 plus negative x minus 2 squared plus negative x minus 2 cubed plus dot 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 plus negative x minus 2 all to the n. So we're halfway home, right? We substituted. We're okay shape on the denominator, but the numerator is not supposed to be a 1. It's supposed to be an x, and so how do we get it to where we want it to be? Just multiply by x, that's right. So if I multiply by x, I get x over, let's just go ahead and write it what it's supposed to be. 3 plus x is equal to, I'm going to multiply everything on the right side by x. So this would be x plus x times negative x minus 2 plus x times negative x minus 2 squared plus x times negative x minus 3 cubed plus dot dot dot. And then my nth term would get the same sort of treatment. There we go. Okay, so that would be the series there.
Can you simplify?
You definitely can simplify. I mean, it would involve some foiling and potentially cubing of a binomial, but
Be useful to simplify.
it's possible. I mean, if this is where the question terminated and it just said write that, I mean, we've got it. Let me think here. You know what? I'm looking back at the wording. I'm going to make a point with this. I think I'm going to take your question, and I think there's something really important that we should talk about here. It does say, right, the first 4 terms. And the way that it's currently written, we really don't have the first 4 terms clearly defined, do we? No, we don't. We really don't. Because it's a power series, so a power series goes in order, from left to right. It should increase in degree of the exponent. Like the power should go up. Whether it's 1, 3, 5, 7, 9, or 1, 2, 3, 4, 5, or 2, 4, 6, 8, 10, or whatever it is, the power should progressively go up in some sort of pattern. So I think what we'd want to do here, to get technically the first 4 terms, we would want to simplify a little bit. So first term, no problem. It's x, right? Second term, also not too much of a problem. I would just distribute that x across, so that would give me minus x squared, and it would give me minus 2x. And this is actually a pretty important point, because wouldn't that third term combine with the first term? And so we really only have 2 terms. Even though it looks like we have 3, we really only have 2 terms so far. So I'm going to go a little bit further with this. It looks like I'm going to run out of room somewhat. I think, though, if we FOIL that negative x minus 2 squared and then distribute, I think we'll have the 4 terms that we need. I think. We'll find out. So let's see here. The FOILing would be x squared plus 4x plus 4. Correct? Got to still distribute the x. So I'm going to come down here. I'll erase this because I obviously am running out of room. So it'd be x minus x squared minus 2x. Distributing the x, I'd get plus x cubed plus 4x squared plus 4x. Looks like I only have 3 terms right now, huh? If I combine all my like terms, I would have, what do I have, 3x? And then 3x squared. And then so far plus x cubed. So, Will, I'm really glad you asked about this because I was just going to brush over it. The truth is, even at this point, I've kind of left this off. I haven't done anything with this yet. At this point, I really only have 3 terms, right? And so to write the first 4 terms, any like similarly degreed terms need to be combined. So to truly get that 4th term, I don't know if I'm going to go there here this morning because of space and time. This is probably a little more than I would expect on a quiz as far as like, cubing a binomial. But we would have to cube this and distribute the x, and that would allow me to tag on my 4th term eventually.
I can tell you what that is.
Sorry?
I can tell you what that is.
Let's do it.
It would be minus 8x minus.
And so you are,
Once it's distributed.
once it's distributed.
X.
Before, Reagan looks like she has a pressing question.
I'll
No.
go after.
Okay, fair enough. Okay, so you said
Minus 8x minus 12x squared minus 6x to the 3rd minus x to the 4th.
okay, we're going to trust Grace. I'm sure she did a great job. So this is, so 4x, you said 4x minus 8x. No, it started right here, didn't it? There we go. Okay, so this is going to change our x term a little bit, isn't it? And it's going to change our squared term, and it's going to change our cube term. Yeah, this is going to go a little bit far, isn't it? Because of the way it's worded, it says write the first 4 terms. This is going to change some other stuff here. Yeah, I don't know. This would probably be a really bad quiz question, I would say, because this thing is going to continue to get tangled up, right? Because if you do the 4th, you're going to get some other variations on x's. Eventually, we're going to get out of them, I guess. No, it's going to continue to be super tangled up, no matter how far you go. So let me just sum it up like this. This would be a good point because of your question. This one is going to get really twisted up forever. And I don't know, Reagan, if that was going to be your point. No. But I think every time if you think about this, every time we multiplied out a binomial, aren't we going to get an extra something or other x? As well as probably an x squared and an x cubed. It'll just increase the degree by a little bit each time. So to truly say, let's write the first 4 terms, I don't know that I could really ask that question here. So this is kind of a bad question. To go back and look and see where I got this. I don't know if I made this one up or if I got it out of some test prep book or whatever. But my point still stands in regard to your question. If you are asked to write the first 4 terms, we at the very least need to seek to combine like terms, essentially, is what I'm saying. We need to simplify it down to that point. We don't want to leave these, unmultiplied things out or uncombined like terms. Yeah. Okay, Reagan, to your question.
So, I don't know why my brain decided to do this, but instead of doing that for the substitution, I did negative 1/3 x and then multiplied.
Okay, slow down. You did negative 1/3 x. You substituted negative 1/3 x.
So that it becomes 1 plus 1/3 x, and then multiplied that by x over 3,
Okay.
so that it all cancels.
Interesting.
And so I got, it made it really easy for me to do the 4th term thing.
So okay, interesting. Okay, so
But is there any reason that would have worked? Because it's a very different answer.
great question. So there's a difference between what we did, and I like what you did. This question was not clear as far as what it expected of us. What you did is you created a power series centered at 0. Right? Because think about what you substituted. You substituted negative x over 3. Okay, I get that. So we substituted negative x minus 2. So we shifted the centering point, didn't we? We shifted the centering point from 0, which is what it originally was, to, bless you, to negative 2. Something different. So if, perhaps the better way to approach this from a question standpoint would be to say what I want the centering point to be. Does that make sense? So yeah, maybe a little bit of an unclear question, because your way, it sounds like that makes sense that you would have an easy way of finding the fourth term, because you kept your centering point at 0, so you didn't get all these negative x minus 2's. I like that idea. But your way is perfectly valid. As to whether your way is right or this way is right or wrong, I'd say the question leaves that open, doesn't it? Because it doesn't say leave the centering point at 0 or put it at somewhere else. So I don't think that you could reasonably say one is right or wrong. This one, certainly to get the fourth term, becomes very problematic, the first 4 terms, right? Your way, not so difficult.
So it does still.
So your way is totally valid, totally valid. It's just different. And as far as finding the first 4 terms, it's starting to sound better, not necessarily right or wrong, but better as far as finding the first 4 terms. Yeah, great question. Thanks for asking. Did you guys get that? Did that make sense, what she asked? She did a little different substitution and a slightly different multiplication, but she kept her centering point at 0. We moved ours to -2. It made a difference. So if I'm going to expect one thing or the other, I'm going to try to write that into the question so that there's less ambiguity. Yeah, great, cool. Okay, we got time for probably one more here, and that'll leave us in pretty good shape for Monday. Just so you guys know, on Monday when you come into class, one of the very first things we'll do is on the board, I'll say, hey, let's write out all the power series again. It'll kind of be your last chance before your quiz to show that you know what's up. This will be a perfect transition. Okay, so number 9, let's do this really quick. Number 9 says use the Maclaurin series for sine of x to evaluate that limit, and we can briefly discuss why this works. So what we're going to do is follow the directions. We're going to use the Maclaurin series for sine. So check this out. It's going to be the limit as x goes to 0. And then in place of sine of x, I'm going to put the Maclaurin series for sine. So I'm thinking about a quiz or a test. If you don't have those memorized, this question is going to feel impossible. Or you could maybe construct it with the Maclaurin construction. So then it would go from impossible to just long. But if you already know the series, it'll be pretty short, relatively easy for you. So sine is it still up there? It is still up there. X minus x cubed over 3 factorial plus x to the 5th over 5 factorial. Didn't say exactly how many terms. You're going to find out, I think, pretty quickly that it doesn't particularly matter. So I'll just put plus dot 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 whatever minus x all over x cubed. So if we do a little bit of simplifying here, wouldn't the x on the front of the Maclaurin series add out with the minus x that was already there? Yeah? So this would add out with this. And then we'd do the division. So we'd say limit as x goes to 0, and it's going to be negative x cubed over 3 factorial plus x to the 5th over 5 factorial. I'll put one more term on there just to make it look a little more official. All over x cubed. But wouldn't that x cubed then be able to be canceled out of all the terms in the top and the bottom? So then we could rethink this through and say, okay, now simplify this as really the limit as x goes to 0. Wouldn't it be negative 1 over 3 factorial plus x squared over 5 factorial minus x to the 4th over 7 factorial plus dot dot dot? The point being that once you get beyond that negative 1 over 3 factorial, won't every single term beyond that have an x in the top? X to the whatever. And as you apply the limit, the x to the whatever goes to 0. So that means that every single term from there to infinity will become 0, leaving only the first term in that, which is negative 1 over 3 factorial, also known as negative 1 over 6. As to why this works, the reason why this works is because the interval of convergence of sine is from negative infinity to infinity. In other words, we can perfectly represent sine with that power series. Therefore, we can know for certain that this limit is exactly negative 1/6. Because I would challenge you, before you go, I would challenge you to think of some other way to do this limit. There is a way. What is it? Could you do L'Hopital's rule with this? Kinda, sorta, right? You could do L'Hopital's rule and eventually get there. I think you'd find the same answer, wouldn't you? You could try it out if you wanted to later. But yeah, L'Hopital's rule to get there. That's the only other way. This would be another way to do it. So, all right, have a wonderful day. See you guys on Monday. That'll be our last regular class of the year, to be honest. Last regular class of the year. Because beyond that, we'll be testing, reviewing, or Apriling. One of those things. Have a great weekend.